Okay, so those are the two key things from the syllabus in the beginning. Now, the next key thing is the textbook. So let's switch up colors for this one. We'll go green. So the textbook, not required, but highly recommended. I guess I should spell recommended correctly. There's two M's in recommend. We're starting this semester off perfectly. O'Grady's back to misspelling fourth grade words. And again, if you buy, you'll see this on the syllabus. If you do buy the textbook, you'll have access. And technically you don't need to buy the textbook. You could buy the access code. I mean, I'm sure most of you have been in college now. You understand that most textbooks have digital access codes now. Some of you probably used that for math class before. I don't like to do it, but it's there if we need it. And it's extra credit if you want it. And by the way, there are so many resources online that are free. You don't need the textbook. There's plenty of free resources online. But again, if it were me, I would buy it. But I understand that some of you, either don't want to or can't afford the, who knows, it's probably like $300. You want to get into a good racket. The textbook business, man, they're one of the few businesses that just keeps profiting over and over and over again. It's making money. Okay, now the last thing I'll say about the syllabus before we do some math, because this is important. Everybody's worried about this. All you guys do is waste your time worrying about your grades. I'm not going to go through the details now, but there's 4 components to it. Homework is going to be 100 points. And then exam 1, exam 2, and then we're going to have a quote unquote final, whatever you want to call it. These are all 100 points each. So that's 400 total points. And then there's a grading scale and all that. You can figure that out. It's on the internet. So what I'm doing here is I'm allowing you guys a very, it's pretty balanced. Everything is equally weighted. Your finals weighed the same as the exam 1. Your exam 1's weighed the same as your homework. So what this is going to mean for you, and the reason I set it up this way is you have to really concentrate on getting high points on the homework. They're going to be 10 points each. There's going to be roughly 10 homeworks, so 10 points each. Because that can really help your grade if you don't do as well as you'd expect on one of the exams. Here's another fun fact that since this is a online or whatever the heck you want to call it, this might make you feel, I don't know if it'll make you feel better or worse, but we'll talk about this more as the semester goes. All exams are quote unquote take home. So what that means is I'm going to give you an exam and then you're going to have some finite amount of time to solve it and submit it. It's not going to be online. It's not going to be like multiple choice on Canvas. It's not going to be anything like that. It's going to be very similar to your homework. You write up solutions, scan it, and upload it. Any questions about grades? Like Heather, you probably have to get a good grade, right? Because then they won't refund you for the class. Is that how that works? Yeah, so you can't flunk or you're broke. So there you go. What the, can you hear my kid up there? She's talking about sending her Legos to jail. How does a 5-year-old know what jail is? I don't know. Yeah. Now my mom says you don't go to jail for that. This is the world we're living in. Welcome to the Roni 2020. All right. Does anybody have a question or a comment? I need to come up with some cool Zoom background, because all you're seeing is like the kids' playroom. We'll give you a tour of the O'Grady house one of these days. It'll be so much fun. Oh my God, there's 7 of us now. This is cute. Someone just joined. I don't know who the hell it is. All right. Cool. Oh, by the way, if you're hearing me out there and you're not a LaRoche student, do me a favor and email me so I know. I would usually ask you all this stuff if we were face-to-face, but we're not face-to-face. Okay, so that's all I really want to say about the syllabus. You can read all the details, and if you have questions, you can email me, or you can ask questions on, Canvas, whatever you want to do. It's 10:30, cool. All right. Whenever you say, does anybody have a question, you're supposed to wait 10 seconds before you move on. That's what they taught you in speaking class in high school. Okay. So let's do some math. Let's stimulate your brains, hopefully. And some questions I would like you to think about. Now, what I would highly encourage you do is not just think about them for 5 seconds, not just think about them right now, but when you got a moment where you're doing your studies, give it some thought, write things down, brainstorm, if you will. So the first thing I would ask you to consider, and you're probably not going to know the answer, because if you were, well, if you did know it, you'd be like, well, what am I here for? What is calculus? You don't have to say anything right now. I'm not even suggesting that you know the answer to this, but what I'd like you to do is think about it. What do you think it is? And like, if I were to, I'll probably put this question on your first homework, and I know I'll get some good answers. Like someone will say hard math, or someone will say it's math, but and that's fine. We don't really think, or you should know what calculus is right now. What would a mathematician say calculus is? What would an engineer say calculus is? What would an epidemiologist, speaking of the Roni, what would an epidemiologist say calculus is? So that's a question that we'd like you to think about, and I'm going to give you 2 hints on how you can really think about it. And the first question for a hint, and these are not just modern hints, they're also from a historical perspective. You might ask a question like, what is area? Every one of you has used the word area in your life. There's no doubt about it. In school, you calculated areas of squares and rectangles. You might even know the area of a circle formula. But if I asked you to define the word area, if I said write down a definition of area, could you do it? So let me get your mind a little more sort of stirred, hopefully. Here's a rectangle. When you were a kid, you learned that if this rectangle had a width x and a whatever you want to call it, other side was y, you were taught that the area equaled x times y. That was a formula you guys learned as kids. A rectangle. Right? And then you even talked about other shapes, like someone would teach you what this is, and then, you know, the next day they would draw something like this. They would draw a right triangle, and they would say, hey, if you take a rectangle and you cut it across its diagonal, you get this triangle, and you might call this the base of the triangle, and you might call this the height, and you were taught that the area was 1/2 times the base times the height. So these are formulas that were taught to you when you were a kid in elementary school. And once you learned these shapes, then they would build these other sort of what we call polygons. And they would build polygons by taking triangles and putting them on top of each other, side to side. Or you could take a polygon, if you remember what a polygon was, and you could chop it into pieces that were triangles and rectangles. So we have this notion of what the area of a rectangle is, and we have this notion of what the area of a triangle is. At least you might remember these formulas from your days in a school or taking standardized tests when you were in middle school or high school. But in general, what is area? Because if I go to the next page and I draw something like this, what does area mean? Now, you might say the space enclosed, and I would say, okay, that's fine. But then how do you calculate it? And I can even get even more sort of confusing. And what if I drew something like this? I mean, at least the top picture, we have some intuitive notion of what area is. But what does that mean for that black curve that crosses itself a bunch of times? When I say area, the first thing that often comes to our minds as humans is we often think the space enclosed. Now that makes sense for the top picture with the blue, you know, it makes sense that there's some enclosed region in here. But when I look at that bottom thing, if I say what's the area and your brain says the space enclosed, well then it might be much more ambiguous. Do I mean how much space is the black marker taken up on the white? Whatever that means, space. So what we find is the following. And if you have a question or comment, please speak up. And by the way, you don't have to like raise your hand. You don't have to like, you know, if you have something you want to say, you're paying money, just say it. As long as it doesn't offend people. Let me be the one who offends everybody. That'll be how we do this. And I'll be equal opportunity offenders. I'll offend everybody. We'll do athletes, we'll do politicians, we'll offend myself. That's what we do. I have a sip of my chemicals. This is not a beer, by the way, it's a rock star. I drink these. Okay, so here's what we have that's quite interesting. If we go to the next slide, it turns out that defining area and what we'd say size in general is very difficult. But not luckily, calculus gives us a way to do this. So the first big picture item for us today is that an intuitive human concept, this idea of size and area, is actually much more difficult than we might think. And not only is it difficult in the sense that what I just said on the previous slides, think about it from an evolution of human civilization. If we go back and look at what humans have been thinking and questioning thousands of years ago, as far back as we have written history, humans were curious about size. Fast forward all the way up to the 1600s. So calculus was invented technically in the 1600s by this guy Newton, who you've heard of probably, Isaac Newton, and some other guy you've probably never heard of named Gottfried Leibniz. So they invented this new type of math called calculus, and what it did is it helped us to define area. So put it in perspective, humans have been curious about size since as far back as we've existed. And it wasn't until the 1600s when we were able to actually make a definitive definition of area. So that means we're about to ask you something, to learn something that's so difficult, I guess, quote unquote difficult. It's really not that difficult, but it took lots of pieces to be placed. You know, you can't just get to the top of the ladder unless you climb all the rungs, right? And so in order to define area, we needed this notion of calculus. And so one of the things we're going to teach you this semester is how to define area. Now, of course, you might say, well, that's boring. Who cares? What if I don't care about area? And I would say, cool, I get it. Not everybody cares. But what's amazing is this notion of area is connected to another notion you're familiar with that you still couldn't define. So let's transition into that. What is velocity? This is another one of my favorite questions to ask you. You've used this word or used its cousin word, speed, all the time. Heck, every time you get in a car and you drive, you're looking at your speedometer. So your mind has an intuitive notion of what speed and velocity are. But once again, could you define it? So these are things, again, remember, I started this off 5-10 minutes ago by saying these are questions we'd like you to think about. What is calculus? What is area? What is velocity? Does anybody have a question? Comments? You can say anything. It doesn't even have to be about math. It can be about life. It can be like, it's a beautiful day. Who's going to go sit by the pool when it's 90 degrees? Yeah. All right. So here's a long story short. Area and velocity turn out to be related. If I could spell correctly, it'd be ideal. So to define them and important for applications, compute them, what we need is we need the language of calculus. So here we have two historic questions that humans were interested in. Size. I mean, the concept of area goes back to the beginning of time. I mean, think, you guys are adults. I think you're all adults. I don't know how many of you like live on your own, but when you live on your own, they like to do this thing called tax you. And they like to tax you on how much property you own. And so literally you can trace computing the size of land, and hence understanding area goes back as far as we have written history. And even back then, the great minds were also interested in things like velocity. How fast is something going? What does that even mean? If I'm protecting my castle and I need to have projectiles to launch over to fight the enemy, how do I know what angle to launch them? How do I know what speed they need to go? How do I know when they'll land? I mean, we could sit here over and over again and give examples of situations where computing size and understanding how something moves. And it doesn't have to be something that's physical. When we use the word velocity here, or the word that you're probably more familiar with, which is speed. Now, velocity and speed aren't the same thing. We'll talk more about that as the semester goes on. But if you want to think of the word velocity, you can think of it as a more general thing. It's how something changes. It's how we quantify change. And then if you start thinking about quantifying change, you start to see intuitively how area, or size in general, size, and velocity should be related. Because you imagine, like some of you probably have done before when you're in a car traveling. You imagine, well, if I go this speed for this long, here's how far I've gone. Or you might do it the reverse way. You might say, well, hey, I traveled this distance in this amount of time. So then you can figure out, well, this is how fast I must have been going. I don't know, maybe you don't do that. But when I travel, I get on a highway and I say, oh, if I go this speed for this amount of time, here's what I'm going to get where I want to go. And so if you start thinking about that, you start to see how area or size in general, distance, is related to speed or change. But these ideas don't necessarily also have to be, I keep using this physical thing of speed in a car, but one of the things that you guys might know a little bit about, or maybe you don't, are things like change in other areas, like change in interest. Many of you are probably using student loans. Like most of us did. Or maybe one day you'll buy a house, or maybe you'll have a job that gives you a retirement and you invest into the stock market. Maybe you're interested in understanding what's the difference between something like a Roth IRA, if you even know what that is, versus a savings account. So there's this little thing that's hidden in that, like in your credit card bills or in your mortgage or in your student loans. It's called compound interest. And basically what we're saying is, okay, the value of your debt changes. How does it change? Well, it depends on how much you pay it off and how frequently you pay it off. The value of your savings account changes. It changes based on how much money's in there, how much interest are they giving you, and how much do you take out. So when we talk about velocity, we're using that word in a physical sense, but the more general word would be change. How do things change? How does my body react? How do things inside of my body change when I put 240 milligrams of caffeine? How does your blood change when you drink a bunch of margaritas if you're 21? Right? What happens to your blood over 8 hours if you take a painkiller because you have a sore tooth? The ideas that led us to calculus were area and velocity. But it turns out that these ideas are much more general. And when we get to the 1600s and Newton and Leibniz invent this thing we call calculus now, what they invented is they invented a language that can help us describe change. So that's really what calculus is. If you wanted, most mathematicians, myself included, if we were going to tell you what is the definition of calculus, we would say it's change. It is the mathematics that lets us quantify change. Are you making money? If so, how fast are you making money? Are you losing money? If so, how fast are you losing money? Is the population growing? We see this right now. What's this big nonsense with the corona? No, I shouldn't say nonsense. But one of the big problems we have is, okay, what rate is the population going to be infected? You maybe have watched the news and paid attention to this thing called R0, this what they call the reproductive number. At what rate? How rapidly will it spread? How rapidly will it die out? To answer these questions, we use calculus. Calculus is the language of change. And when we use the word change, we don't just mean physical change. It can be something like a bank account. It could be the population of fish in a local lake. So one word I want you to have on your brain starting today is change. So I'll let you ponder that. And does anybody have a question? So calculus is the branch of math that studies change. That's the way you got to think about it. Does anybody have a question? Now, in many ways, you can argue that calculus and math in general is a language. And it is. And like any language, it's not easy to learn unless you're constantly being around it. I mean, you're not going to learn a second language like Spanish or French by doing 15 minutes of Spanish studying a week. You're just not. What's the best way to learn Spanish? Probably the best way is to go get on an airplane and drop yourself off in a country that speaks Spanish. Or sit around all day and watch television shows in Spanish. Calculus is very much the same. What we're going to do in this class is conceptually difficult. If you know, you might already have that sort of preconceived notion. But even if you didn't, just think about what I told you. We're going to ask you this semester to learn something that took humans thousands of years to figure out, right? The other irony of that, though, is what we're going to teach you in this class was groundbreaking science in the 1600s. So you're learning something that's pretty old. You don't really do that in other subjects, right? You're not in biology learning about the medical practices in the 1600s, right? Because if you were teaching people that still, we'd all be dead. The theories we had, and I mean, really chemistry and physics, did they even exist back then? Not really. Everything back then was called philosophy. Anyhow, we're getting off topic, but the point of the matter is this stuff is challenging to learn. And if I sort of transition into the next piece, what makes it challenging is the material itself, but that's also compounded because most of us, when we take calculus, and myself included many years ago, is we don't really know the prerequisite material well enough. So what does that mean? Well, learning calculus is difficult on its own, but when we're not really, really well-rounded in things like algebra or trigonometry or geometry, it makes learning calculus much more difficult. As you guys are well aware, to do math, the language in which we speak, I guess, is symbols. It's symbolic. We use letters and numbers, and we use logic to reason things. We have equations and expressions. And so there's all this stuff that we sort of hope that students would come to a calculus class knowing, but we know that's not the case as instructors. So one of the things that you're going to have to do is convince yourself early, like starting now, that you're not going to let scary symbols and algebra and sines and cosines and all these things that you were supposed to have learned before you got here. Excuse me. You have to understand that A, we forget things. B, that's okay that we forget things. C, even some of that stuff is not easy to learn. And so what I'm trying to do is encourage you to understand that learning, you know, in my opinion, learning anything in science, mathematics is difficult. And one of the things you have to do is keep reminding yourself that you're going to fail more often than you'd like. And I don't mean fail the course. I'm not saying you have to get an F the first time and then a B the next time. What I'm saying is learning this stuff is a process. It requires lots of trial and error. It's going to require lots of you failing. Just like, you know, I use this analogy all the time, or metaphor, whatever you want to call it, because I have a kid I have a 5-year-old and a 2-year-old. And you don't realize how learning is such a process until you watch kids all the time. You know, none of you came out into this world and started walking just because you watched people around you walk. I mean, think about how complicated walking is. It takes humans about a year to figure it out. And then once you figure out walking, you think you're a smart ass and you try to move fast and then you fall again, right? So I encourage you to think about learning calculus in that way. There's going to be lots of problems that you don't even know where to begin unless someone helps you. And that's okay. There's going to be lots of problems that you're going to watch me do, or you're going to watch someone else do. And you're going to think that oh, I get it. And then you're going to try it yourself 3 hours later and you're going to have no clue. You're going to mess it up. That's the process of learning. So you got to keep in your mind the big principle that this is hard and it's a process to learn it. So you just can't get upset and disappointed and discouraged. That's no good. What you have to do is you have to say, all right, I know I'm going to mess things up, and that's okay. That's where I come in to help. That's where tutoring services. I should have mentioned this earlier. I'll definitely mention again. I don't care how good of a student you are, you should just get a tutor for calculus, especially if it's free. The school provides free tutoring, so use it. I think it's all online now, but use it. It's free. And then work together if you can. The best way to learn is to teach. And I always joke about this. I call it the blind leading the blind. One of the best ways for you guys to learn is try to explain things to someone else. And even if you don't think you know it, believe me, you'll learn from it. Does anybody have a question? Comments, concerns? Anything? All right, so here's what I'd like you to do. I'd like you to think about this. I'm going to post, as I said, your first assignment and the syllabus to Canvas. Should be up sometime this afternoon, if not sooner. And once that stuff's ready, you can work on it and email me with any questions, and we will talk about these problems. Oh, by the way, I should mention the first assignment you're going to get is going to seem long, and it's going to probably seem hard, and that's okay. We're going to do a bunch of the stuff together on Thursday. But if you really want to get learning from it, if you want to optimize how much you learn, I highly encourage you try all these problems before Thursday. Because if you don't try them yourself, you're not going to learn as much by watching someone else, show you how to do them. The key observation in learning, at least in my experience, is to try something multiple times, and if you don't get it, see where you went wrong. That's how you learn. So that's my opinion and my advice, I guess, is a better way of saying it. So the last thing I'll say about this homework is do not get discouraged if you can't do any of it, really. You should be okay for most of it, but there's going to be some of it you don't know. And you got to think about this first homework as sort of like if a calculus instructor had the ideal student in calculus, what would they know coming in? How good would they be? So don't take this as like we expect you to know all these problems. Take it as in the greatest world that we could imagine, every student coming into calculus would be able to do this. So again, I'm not expecting you. It's kind of like a dream. I don't know if that makes any sense. Anyhow, so what I'm going to do, if you don't have questions, is I'm going to end this quote unquote first lecture. We'll meet again Thursday, 10 o'clock. We'll talk some problems. We'll talk about all kinds of stuff related to the class.
I can turn off my
Someone had a question?
Okay.
It doesn't have to be on.
Hello?
Oh, is your camera off?
Yeah.
Okay, because you have your hood up.
Okay.
So, what are you doing with your phone?
All right. So if you guys don't have any questions, no, there's 8 people. People joining late. I like it. It's so nice. All right. I'm going to end. If anybody has any questions, stick around. If you don't want to talk out loud, I get it. You know, we're shy. So I'm going to end the recording now.